create a point with coordinates 100 and represent it as a vector with start at the origin and end at the point 100. If we would like to multiply this vector by the scalar 2.0, we would simply multiply the coordinate 100 with 2.0 and the result would be a vector with twice the length, 200 in this case, but the same direction. If we would multiply by a negative scalar, for example, minus 2.0, the result would be a vector with length of minus 200, which means it would point in the opposite direction compared to the previous result. In multidimensional space, we would simply multiply each component of the multidimensional point with the scalar to get the final result. We're going to take a look at this shortly. In two-dimensional space, we add the second y-axis perpendicular to the original x-axis of the one-dimensional space. Now we have a plane containing an infinite number of points with two coordinates, x and y. Again, there is a special point with coordinate 0, 0, which is the origin. In MaxScript, a two-dimensional point is expressed as a Pt.2 value. A Pt.2 value can be constructed by using the Pt.2 constructor and then the two coordinates, or by just specifying the coordinates in rectangular brackets. Such values are very often used to represent image coordinates, screen coordinates. The function mouse pos returns, for example, the position of the mouse relative to the upper left corner of the viewport. The function mouse screen pos returns the position of the mouse pointer relative to the window origin, and so on. The Pt.2 value can be also represented as a two-dimensional vector connecting the origin of the coordinate system and our point. The x-coordinate of our Pt.2 value can be seen as the projection of the two-dimensional vector onto the x-axis of the coordinate system. We can also represent it as a one-dimensional vector in the space of the x-axis with length equal to the x-coordinate of our point. The same can be said about the y-coordinate. It's another vector, a one-dimensional vector in the space of the y-axis with length equal to the y component of our Pt.2 value. Since vectors can be freely translated without changing their direction and length, we can translate the y projection vector so that its start is moved to the end of the x projection vector, and the result is the typical vector addition, this time in two-dimensional space, where the end of the first operand is the beginning of the next operand, and the result, the sum of the vectors, is calculated by connecting the beginning of the first operand and the end of the last operand.